for today's lesson, we are going to take what we learned about long division and synthetic division and now solve equations using long division and synthetic division. Before we get started though, I want you guys to practice factoring 27 minus y cubed and x to the 5th power minus 2x to the 4th power minus 16x plus 32. Remember that whenever you see 4 terms, you'll have to use factoring by grouping. And whenever you see a difference of 2 cubes, that means that you'll have to work with SOPs. Go ahead and pause the video and factor each of these expressions. And then when you're ready, go ahead and restart the video and we'll see how well you did. All right, so hopefully for the first one, you were able to see that this is a SOP situation. So what we want to do is we want to set this up as a binomial times a trinomial. In our binomial, we're going to take the cube root of 27, and that is equal to 3. So 3 will go into the first position, and in our second position, I'm going to have a minus sign because it's going to have the same sign as what we started with. And then the cube root of y cubed, that's equal to y. So we have 3 minus y. Now we're going to do square opposite product square using our binomial. So we have 3 squared, which is 9. The opposite sign is a plus. Product is 3 times y, so that's 3y. And then squared, we'll have negative y times negative y, which is positive y squared. And that is your answer. If you want to rewrite it in standard form, that's fine. You can rewrite this as negative y plus 3 times y squared plus 3y plus 9. That's not a problem at all. Both the ways I would accept either answer, especially if the problem started off being not in standard form. For example number 2, it has 4 terms, so what I'm going to do is put parentheses around the first 2 terms, change my minus to be a plus negative, and I'm going to put parentheses around the last 2 terms. Next, I'm going to identify the greatest common factor, and in this case, that's going to be an x to the 4th, and my leftovers is an x minus 2. Then I'm going to write a plus sign, and negative 16x and 32 both have in common a negative 16, with our leftovers being x minus 2. So now I'm going to write 2 parentheses, and inside of my 2 parentheses are going to be my outsiders, which are x to the 4th minus 16, and my insiders, which is x minus 2. It looks like I'm done, but I'm actually not. X to the 4th minus 16 is a dots, so I'm going to have to break that down even further into 2 more parentheses. So now I have an x squared plus 4 and an x squared minus 4. And it looks like I'm done, but I'm really not. X squared minus 4 is another dots, another difference of 2 squares. So I'm going to have an x squared plus 4 times an x plus 2 times an x minus 2 times another x minus 2. And if you want to write it fancy and you notice that both of these are an x minus 2, you can rewrite this as x squared plus 4 times x plus 2 times x minus 2 squared. And that is your final answer. So for these types of problems, you always want to think outside of the box and try to break them down, any polynomial or any parenthesis down as far as you possibly can. So like I said in the beginning, today we're going to be working with synthetic division as well as long division to solve polynomial equations and to identify the x-intercepts of a polynomial function. Then we're going to solve real-world applications of polynomial functions. So, like I said, we're going to be working with synthetic division. I want you to be able to say, I can use synthetic division to factor. So we're going to be factoring polynomials and solving equations so that we can find every 0 or x-intercept. So all of our goal is to find all x-intercepts of our polynomial. And then we want to solve real-world application problems. And there will be a real-world application problem, one of the ones that we're going to be talking about. One of them will be on your test, and I want you to please make sure that you understand what's going on for those. So what does it mean if you end up with the remainder of 0? So in the problems that we worked with yesterday, our remainders ended up being crazy. They were a lot of really weird numbers. So what happens if that remainder is 0? What that means is that there is no remainder, and it divides into the polynomial evenly, which means that the polynomial is factorable, and we can actually factor it. So what we want to do is we're going to receive a problem, and if you end up getting an f of k is equal to 0, that means that it's factorable. That's all this is saying over here. So for example number 7, it says, given a polynomial and a factor of the polynomial, factor it completely. And then after it's factored completely, we are going to, for examples 8 and 9, we're going to identify the zeros. So we're going to factor the polynomial completely. And then we're going to, you're going to have to do factoring to a whole new level. So it says, hint, after dividing the given factor, factor the quotient, and then rewrite using all factors. So those are your steps. I know it looks kind of confusing, so let's just hop right into a problem. The first thing I'm going to do is I'm going to take this x minus 3, and what's cool about it is it's in the structure for us to use synthetic division. So I'm going to say that my x-intercept that would be produced by an x minus 3 would be a positive 3, and that's what I'm going to put inside of the box. Next, I'm going to make sure that all of my degrees are represented, and I have a 3, 2, 1, 0, which is awesome. I don't have to insert any 0 x's or 0 x squares. So I'm just going to write 2, negative 11, 3, and 36. I'm going to draw a vertical line and a horizontal line. I'm going to bring down the 2, and I have 3 times 2, which is 6, and I'm going to add going straight down. Negative 11 plus 6 is negative 5. 3 times negative 5 is negative 15. 3 minus 15, that's equal to negative 12. Then 3 times negative 12 is negative 36, and 36 minus 36 is 0. What's awesome about this is that we can factor. We now have ourselves a 2x squared minus 5x minus 12, and this polynomial is factorable. So far this is what we have. We have an x minus 3 times a 2x squared minus 5x minus 12. That's what we have so far. And what we're going to do is we're going to break down this 2x squared minus 5x minus 12 even further. We're going to factor this into 2 parentheses. So we still have an x minus 3, but now I'm going to break down this quadratic into 2 more parentheses. Splitting apart the 2x squared into a 2x and an x, I need to look at the factors of 12, and somehow I need to come up with a 5. So looking at 12, I always think of 3 and 4, and then 2 and 6, and then 1 and 12. Those are the ones that I think of first. So I'm going to put 3 right here and 4 right here. So my goal is to get a negative 5. So I have 2 times 4, which is 8, and 3 and x, so I have an 8 and a 3, and if I make 8 negative and 3 positive, I will end up with a negative 5. So that would mean that I would need a negative in front of the 4 and a positive in front of the 3. And there's my factorization. That is it. That is all you do. Let's go ahead and look at letter B. For letter B, I need to identify the x-intercept that would be produced by x plus 1, and that would be x equals 1. So that's what's going to, or x equals negative 1, so that's what's going to go inside of the little box. Next, I'm going to make sure that all of my degrees are represented. I have a 3, 2, 1, 0, which is awesome, so I don't have to insert any random zeros. So I'm going to write 1, negative 6, 5, and 12. I'm going to draw a vertical line and a horizontal line. Bringing down the 1, I have negative 1 times 1, which is negative 1, and I'm going to add going straight down. Negative 6 minus 1 is negative 7. Negative 1 times negative 7 is positive 7, and 5 plus 7 is 12. Negative 1 times 12 is negative 12, and 12 minus 12 is 0, which is awesome. That's what we want. We want it to be factorable. So I'm going to use that x plus 1. That's my first parenthesis, and my second parenthesis is going to be x squared minus 7x plus 12. And now I'm going to try to factor the x squared minus 7x plus 12 even further. So I still have an x plus 1, and now I'm going to break that down into 2 more parentheses. Splitting apart the x squared into an x and an x, I need to ask myself what two numbers multiply to equal 12 but together add to equal -7? And that is -3 and -4. So I'm going to write -3 and -4, and here's my factorization. There's nothing more for me to do. So now we're going to take this to one more level, and we're going to find the zeros of a function, which means that we're going to be solving an equation equal to 0. So we're going to set our equation equal to 0 to find our zeros of the function. So if we are given a 0 or an x-intercept, so remember that zeros are x-intercepts, then we know the corresponding factor will divide evenly into f of x. That's what we know. Let me zoom this out so you can actually see what I'm underlining. We can use synthetic division to find the quotient, and then we can factor it just like we did up here. When asked for zeros, we must also set each factor equal to 0 and solve to find them. So just like we've done before, whenever we factored and set each part equal to 0, we would just identify what all of our x-intercepts are. We're just taking everything that we've already learned to a whole new level. So what we're given here is f of -2 equals 0. So what this -2 means is that x is equal to -2. That represents an x-intercept. And x equals -2, that comes from the parentheses x plus 2. So that's going to come in handy a little bit later. But whenever you see f of a number inside of that parenthesis, that represents a given x-intercept. So I'm going to be working with that -2 that's going to go inside of the little box. Next, I'm going to make sure that all of my degrees are represented. I have 3, 2, 1, 0. Awesome. I don't have to insert any funky zeros. So I'm going to put in 1, 8, 5, and -14, a vertical line going through 5 and -14, and a horizontal line going across all of them. I'm going to bring down the 1. -2 times 1 is -2, and I'm going to add going straight down. And I end up with 6. -2 times 6 is -12, and 5 minus 12 is -7. -2 times -7 is +14, and -14 plus 14, that is 0. So that's awesome. I ended up with a remainder of 0, which is exactly what I want. So we're solving the equation x cubed plus 8x squared plus 5x minus 14 equals 0. That's the equation that we're solving. We already know what one of our factors are. That is x plus 2. And now we have just factored it even further, and now we have an x squared plus 6x minus 7 equals 0. So before we even continue going, we need to factor this quadratic even further. So I have an x plus 2, and then I'm going to write out 2 parentheses that equal to 0. Splitting apart the x squared into an x and an x, I need to figure out what two numbers multiply to equal -7, but together add to equal 6. And that is going to be a 7 and a -1. So I'm going to write plus 7 and minus 1. Now that it is fully factored, my x-intercepts are the opposite of what you see inside. So that's going to be x equals -2, which we already knew that, -7, and +1. Those are all of your x-intercepts of that polynomial function. Let's go ahead and look at number 9. So number 9, we want to find all of the zeros, which means that we want to figure out when y is equal to 0, what are our x-intercepts? So I'm going to write 0 is equal to x cubed plus x squared minus 16x minus 16. And we are given that f of 0 is equal to 4. I'm sorry, f of 4 is equal to 0, excuse me. So that means that we already know that x equals 4 is one of our x-intercepts. And that comes from the parentheses x minus 4, because remember, it's always the opposite of what you see. This part right here is going to come in a little bit later, but I'm going to use that 4 on the outside of a box, and I'm going to write 1, 1, -16, -16. I'm going to bring down the 1 and multiply 4 times 1 to get 4, and add going straight down. 1 plus 4 is 5. 4 times 5 is 20. -16 plus 20 is 4. 4 times 4 is 16. And -16 plus 16 is 0, which is awesome. That's exactly what we wanted. We wanted it to be factorable. So now I'm going to use that x minus 4, and I'm going to rewrite the 1, 5, and 4 as a trinomial. So that's going to be x squared plus 5x plus 4. And this is equal to 0 because this is an equation that we're solving. We're trying to find the 0, so the equation needs to equal 0. So I'm going to write x minus 4, and I'm going to break down this quadratic into 2 more parentheses. Splitting apart the x squared into an x and an x, I need to figure out what 2 numbers multiply to equal 4, but together add to equal 5. And that's going to be 4 and 1. So I'm going to write plus 4 and plus 1. So now my x-intercepts are going to be a positive 4. We already knew that. This is going to produce a negative 4 and a negative 1. You can also write this as x equals plus or minus 4 comma negative 1. That's another approach as well. All right, now we have 3 more story problems, and then we are finished with this lesson. So looking at example number 10, it says a company's profit, we're going to call it the letter C. Let me back out just a little bit so you can see the whole problem. It says a company's profit, we'll call it the letter C, in thousands of dollars, and that's going to become important a little bit later, can be modeled by C equals negative 5x cubed plus 6x squared plus 15x. That is where x is the number of items produced in thousands. So the profit is $14,000 producing 2,000 items. What other number of items would produce the same profit? Okay, so the first thing we want to do is we want to use this information that the profit is $14,000. So since C is in thousands, C is going to be equal to, this profit is going to be equal to 14. So it's in thousands, so we just eliminate the thousand part. So that's going to be 14. It's for producing 2,000 items. X is the number of items produced in thousands, so X is going to equal 2. So what we were just given is we were given an x-intercept that comes from the parentheses of x minus 2. So now what we want to do is figure out what other number of items would produce the same profit. So the other numbers, that's going to represent your other zeros or other x-intercepts. So that's what this represents. So what I'm going to do is I'm going to replace the letter C with 14 and solve this equation so it's equal to 0. So I'm going to write negative 5x cubed plus 6x squared plus 15x, and I'm going to set it equal to 14. Now I always want to have my leading coefficient be positive, so what I'm going to do is I'm going to subtract all of my terms and bring it to the other side so that my leading coefficient is positive. So I'm going to add 5x cubed to both sides. I'm going to subtract 6x squared from both sides, and I'm going to subtract 15x from both sides. By doing that, we now have 0 is equal to 5x cubed minus 6x squared minus 15x plus 14. So I have this equation that I want to solve. I am given an x-intercept already, and now I'm going to use synthetic division in order for me to find what my other zeros are. So I'm going to put 2 inside of the box, and I'm going to write 5, negative 6, negative 15, and 14. Bringing down the 5, 2 times 5 is 10, and I'm going to add going straight down. Negative 6 plus 10 is positive 4. 2 times 4 is 8, and negative 15 plus 8, that is equal to negative 7. 2 times negative 7 is negative 14, and 14 minus 14 is 0, which is awesome. That's exactly what I needed. So now I'm going to write x minus 2 times 5x squared minus 4x, plus 4x minus 7. And that's going to equal 0, because remember, we're just rewriting this equation in factored form, and it's still going to equal 0. So I'm going to give you guys the heads up that 5x squared plus 4x minus 7, it's not factorable because there doesn't exist two numbers that when added to, or when multiplied together equal negative 35, yet together add to equal 4. So therefore this is not factorable. But don't worry, just because it's not factorable doesn't mean that we can't come up with an answer. Notice that 5x squared plus 4x minus 7, this is quadratic. So whenever you are given a quadratic trinomial that is not factorable, we're going to use the quadratic formula. So I'm going to write x is equal to the opposite of b. So the opposite of b is negative 4. That's going to be plus or minus the square root of b squared, so that's 4 squared, minus 4 times a, which is 5, times c, which is negative 7. This is all over 2 times a, so that's 2 times 5. So I'm going to write x is equal to negative 4 plus or minus the square root. And if you were to put that whole thing into your calculator exactly as you see it, you will end up with 156. This is all over 10. So now I'm going to separate negative 4 plus or minus the square root of 156 over 10 into two separate equations. That's going to be x equals negative 4 plus the square root of 156 over 10, and x equals negative 4 minus the square root of 156 over 10. And I'm going to come up with an answer for both of them. So whenever you're doing this, please make sure that you come up with a solution for your numerator before you divide by your denominator. So what I mean by that is I'm going to put in negative 4 plus the square root of 156, and I'm going to come up with a number. Then I'm going to take that number and divide it by 10, and I end up with, hold on just one second. Let's change that to a 10. And we end up with 0.84, let's call it 0.849. So this is 0.849. And now I'm going to enter negative 4 minus the square root of 156, come up with an answer, and then divide that by 10, and end up with negative 1.649. Well, since we're talking about number of items produced, the negative answer doesn't make any sense. So my answer is going to be 0.849, but even that number doesn't make any sense because we're talking about producing a number of items in the thousands. So what that means is that we're going to have to take our decimal number of 0.849 and we're going to multiply it by 1,000, and that's going to equal 849 items. So what other number of items would produce the same profit? 849 items would produce the same number of profit. All right, let's go ahead and look at example number 11. For example number 11, it says the profit P in millions of dollars for a shoe manufacturer can be modeled by P equals negative 21x cubed plus 46x, and that is where x is the number of shoes produced in millions. So profit is in millions of dollars and the number of shoes is produced in millions. The company now produces 1 million shoes and makes a profit of $25 million, but it would like to cut back production. What lesser number of shoes could the company produce and still make the same profit? So what is given to us is our 1 million shoes represents your x value. X is equal to 1, and that comes from the parentheses of x minus 1, because that is in millions of dollars. So 1 represents $1 million. The profit is going to be equal to 25. So I'm going to write P equals 25 for it being $25 million. So now I'm going to replace P in my function, and I'm going to write 25 is equal to negative 21x cubed plus 46x. I don't like it when my leading term is negative, so what I'm going to do is I'm going to add 21x cubed to both sides, and I'm going to subtract 46x from both sides. And what's going to happen is we still have our equation that's going to equal 0, but we're going to have 21x cubed minus 46x plus 25 is equal to 0. And even more than importantly, notice that all of our degrees are not represented. So I'm going to rewrite this as 21x cubed plus 0x squared minus 46x plus 25 is equal to 0. So now I have all of my degrees represented. I was given an x-intercept already, and I need to find other x-intercepts that would work to make sense for this problem. So I'm going to put in a 1 inside of that little box, and I'm going to write 21, 0, negative 46, and 25. I'm going to put a vertical line between negative 46 and 25 and use synthetic division. So I'm going to bring down the 21. 1 times 21 is 21. 0 plus 21 is 21. 1 times 21 is 21. And negative 46 plus 21, that is equal to negative 25. 1 times negative 25 is negative 25, and 25 minus 25 is 0, which is awesome. That's exactly what we want. We want a remainder of 0. So now I'm going to use that x minus 1, and my other parenthesis is going to be 21x squared plus 21x minus 25 is equal to 0. Well, you can pretty much guess that 21x squared plus 21x minus 25 is not factorable. So because it is not factorable, we're going to use the quadratic formula to help us to identify what our other x-intercepts are going to be. So I'm going to come on over here and write x is equal to the opposite of b, so that's negative 21 plus or minus the square root of 21 squared minus 4 times 21 times negative 25. This is all over 2 times a, which is 2 times 21. So I'm going to write x is equal to negative 21 plus or minus the square root of, if you put that whole thing into your calculator, you would end up with 2,541. This is all over 42. So now I'm going to separate this into two separate equations. That's going to be x equals negative 21 plus, just a plus, the square root of 2,541 all over 42. We're going to come up with a number for that, and x equals negative 21 minus the square root of 2,541 all over 42. Please be careful whenever you're working with your calculator. You want to come up with your numerator answer first. So that's negative 21 plus the square root of 2,541. I have an answer, and now I'm going to divide that by 42. And that is 0.700198. Please write down 0.700198. There is a reason for why I had you guys write that down, and that's because 8 is in the millions place. Next, I'm going to repeat the process, and I'm going to put in negative 21 minus the square root of 2,541, and I'm going to divide that number by 42, and I end up with negative 1.700198, which doesn't make any sense because it's negative, and we're talking about making shoes, and you can't have negative numbers of shoes. So our answer is 0.700198, but even that doesn't make any sense because how can you have 0.7 of a shoe? And that means we have to go back to figuring out what this number is in, and it's in millions. So what I'm going to do is I'm going to take 0.700198 and I'm going to multiply it by 1,000,000. And when you do that, you find your answer is going to be 700,198 shoes. So if the company produces 700,198 pairs of shoes, then what would happen is they'll make the same exact amount of profit as they would as if they had made 1,000,000 shoes. We have one last example for today, and I'm going to put 1,000,000 stars around it. And the reason why I'm going to put a million stars around it is because something similar to this will be on your test, so I want to make sure that you are prepared. There are two approaches, so I'm going to draw a line going straight down. And it says the volume of a box shown at the right is given by V equals 2x cubed minus 11x squared plus 10x plus 8. We want to find an expression for the missing dimension. And our missing dimension is our height. So we know that volume is equal to length times width times height. So what we can say is that 2x to the third power minus 11x squared plus 10x plus 8, that's equal to 2x plus 1 times x minus 4 times some other parenthesis that we do not know yet. So that's what we need to figure out. So there are two approaches. The first approach that you can use is synthetic division. So this is approach number 1, called synthetic division. So the synthetic division approach says pick one, just pick one of your two parentheses, whichever one looks the easiest to work with. Personally, I think that x minus 4 is the easiest to work with. And so identify the x-intercept. The x-intercept that would be produced by x minus 4 is 4. So that's what's going to go inside of the little box. And now I'm going to write down the coefficients that are given to me. So that's 2, negative 11, 10, and 8. I'm going to draw a vertical line and a horizontal line. I'm going to bring down the 2 and multiply 4 times 2 to get 8. And I'm going to add going straight down. Negative 8 plus 11 is negative 3. I'm sorry, negative 11 plus 8 is negative 3. And 4 times negative 3 is negative 12. 10 minus 12 is negative 2. 4 times negative 2, that is negative 8. And 8 minus 8 is 0, which is awesome. That's what I want. So now I have x minus 4, and I have 2x squared minus 3x minus 2. So now I need to break this quadratic down even further. So I have x minus 4 times 2 parentheses. What's cool is that you already know what one of those parentheses are. It's going to be 2x plus 1. We just need to figure out what the other parenthesis is going to be. So we know that we can split apart the 2x squared into a 2x and an x. And we need to figure out what two numbers multiply to equal negative 2, and our goal is to get a negative 3, and I already have a positive 1. So that means that 1 times negative 2 is going to be, this part right here is going to have a negative 2 in it. So my missing expression is x minus 2. And that is one approach. That's called the synthetic division approach. And this is equal to our volume. It's another way to rewrite our volume. It's an expression answer that is missing. So that was the first way. That was synthetic division method. The second method is a little bit more direct. It is the long division method. The first thing that you want to do if you're going to do the long division method is you're going to FOIL the two parentheses that are given to you. So we're going to FOIL 2x plus 1 times x minus 4. So we have 2x squared minus 8x plus x minus 4. And that's equal to 2x squared minus 7x minus 4. This is going to be our divisor that I'm going to put on the outside of a box. So that's 2x squared minus 7x minus 4. And what's going to go inside of the box is what we started with. That's your 2x to the third power minus 11x squared plus 10x plus 8. So now, just like we did with in our last lesson, we work with our first term and our first term. And we ask ourselves, what times 2x squared equals 2x cubed? And that's an x. So now I'm going to multiply x times every single term. X times 2x squared is 2x cubed. X times 7x is minus 7x squared. X times 4 is minus 4x. I'm going to change all of my signs to their opposite and add going straight down. 2x cubes cancel out. Negative 11 plus 7, that's minus 4x squared. And 10 plus 4, that is plus 14x. And I'm going to bring down the plus 8. Next, I'm going to look at my first term of 2x squared with my new first term of negative 4x squared and ask myself, what times 2x squared equals negative 4x squared? And that is a positive 2. I'm sorry, that's a minus 2. Excuse me. So I'm going to multiply negative 2 times every single term on the outside. So negative 2 times 2x squared, that is minus 4x squared. Negative 2 times negative 7, that's plus 14x. Negative 2 times negative 4 is a positive 8. I'm going to change all of my signs to their opposite and combine going straight down. And I notice that my 4x squares cancel out. 14 minus 14 is 0, so they cancel out. And 8 minus 8, that's 0, so that cancels out, leaving me with the remainder of 0, which is awesome. That means I did it correctly. And x minus 2 is my answer, which is exactly what I got using the other method. I don't care which method you use for these types of problems, but just know that there is going to be something very similar to that on your test. That is the end of this lesson. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.